Good day, learners! We are now again here to discuss about operations with radicals, particularly the division of radicals. So in this lesson, you are expected to divide radicals. In dividing radicals, we use the law on radicals, the nth root of a over the nth root of b, which is equal to the nth root of a over b, and then rationalize the denominator of the radicand. For example, we have the square root of 63 divided by the square root of 7. So we can rewrite this as the square root of 63 over the square root of 7. So we have the square root of 63 divided by 7 is actually the square root of 9. And the square root of 9 is 3. Next, we have to rationalize the denominator of the given expression. Square root of 6 divided by the square root of 5. Take note that to rationalize the denominator, you need to multiply both the numerator and denominator by the radical found in the denominator. So we have the square root of 6 over the square root of 5. We are going to multiply both the numerator and then the denominator by the square root of 5. Why? Because multiplying the denominator by the square root of 5 would be equal to the square root of 25, which is simplified as 5. So we have square root of 6 times the square root of 5 is the square root of 30, while by the square root of 5 times the square root of 5 is the square root of 25. And since the square root of 25 is 5, we have rationalized our denominator. So therefore, we have the square root of 30 over 5. In division of radicals, take note that conjugate pair are two binomial radical expressions that have the same first and second terms but only differ in the sign that connects the binomials. For example, the square root of 6 plus the square root of 5, its conjugate pair is the square root of 6 minus the square root of 5. X plus the square root of 5 has a conjugate pair which is x minus the square root of 5. Simplify 4 square root of 3 divided by 2 plus the square root of 5. To divide a number by a binomial radical, multiply both the numerator and denominator by the conjugate of the denominator. So just like in this expression, we multiply both the numerator and denominator by the conjugate of the denominator. Thus, 4 square root of 3 divided by 2 plus the square root of 5 will be multiplied to the conjugate of the denominator, which is 2 minus the square root of 5. So we multiply both the numerator and then the denominator. Therefore, we have 4 square root of 3 times quantity 2 minus the square root of 5 over quantity 2 plus the square root of 5 times quantity 2 minus the square root of 5. Applying the rules in multiplying radicals, therefore we have 8 square root of 3 minus 4 square root of 15 all over 4 minus 2 square root of 5 plus 2 square root of 5 minus 5. So simplifying further, we have 8 square root of 3 minus 4 square root of 15 over negative 1, which could be further simplified as negative 8 square root of 3 plus 4 square root of 15. To divide radicals of different orders, it is necessary to first change the radicals to the same order. Example, cube root of 4 divided by the 6th root of 2. So we change the radical expression to expressions with fractional exponents. So cube root of 4 is changed to 4 raised to 1/3, while the 6th root of 2 is changed as 2 raised to 1/6. Then we change the fractional exponents to equivalent fractions. So therefore, we have 4 raised to 2 6 over 2 raised to 1 6. Since the denominator of the exponents are already equal, we can turn it back to radical expressions. So we have the 6th root of 4 squared divided by the 6th root of 2. Therefore, we have the 6th root of 16 over the 6th root of 2. Therefore, we have the 6th root of 8. However, this expression, 6th root of 8, is not in its simplest form. So we need to further simplify it by using the law on radicals, wherein we can reduce our index because 8 could be written as 2 cubed. So therefore, we can factor our index as 2 times 3. Therefore, we have the 6th root of 2 raised to 3 could be written as the square root of the cube root of 2 cubed. So therefore, we have square root of 2, which is the simplified form of the 6th root of 8. Another example, we have the square root of 2xy squared divided by the cube root of 8xy cubed. Since the index are not equal, we need to change or transform the expression into expressions with fractional exponents. So square root of 2xy squared is transformed as quantity 2xy squared raised to 1/2, while the cube root of 8xy cubed is transformed as quantity 8xy cubed raised to 1/3. We change the fractional exponents into equivalent fractions. So therefore, we have quantity 2xy squared raised to 3/6 over 8 quantity 8xy cubed raised to 2/6. So we can change it back to radical expression raised to 3 over the 6th root of quantity 8xy cubed raised to 2. So therefore, we have the 6th root of 8x cubed y raised to 6 over the 6th root of 64x squared y raised to 6. So we have the 6th root of 8x cubed y raised to 6 over 64x squared y raised to 6. So take note that 8 divided by 64 is 1/8. X cubed divided by x squared is x, while y raised to 6 divided by y raised to 6, the exponents are equal, so we can cancel it out. So therefore, we have the 6th root of x over 8. We need to rationalize our denominator. That is why we need to multiply the numerator and then the denominator by the 6th root of 8. So therefore, we have the 6th root of 8x over 64. So therefore, our final answer would be the 6th root of 8x over 2. Remember, multiplying a binomial by its conjugate eliminates the radical. Use this strategy when the divisor is a binomial with radicals. When dividing radicals with the same indices, combine the radicals, then simplify. When dividing radicals with different indices, rationalize the denominator, then convert the radicals to exponential form with exponents that are similar fractions. And then lastly, always express the final answer in simplest form. Let us have this activity. So in answering this activity, pause this video to give you ample time in solving the expressions. If you're done, click the play button to check whether your answers are correct. Let us have number 1, 6 divided by the square root of 3. Our final answer should be 2 square root of 3. Number 2, 7 square root of 21 divided by the square root of 7. The quotient should be 7 square root of 3. Number 3. The square root of 8a cubed divided by the square root of 2a. Quotient, 2a. Number 4. Square root of 7xy divided by the square root of 14x cubed y. Quotient, square root of 2 over 2x. Number 5. Square root of 2 divided by the cube root of 2. Final answer, we have 6 root of 2. And finally, cube root of 3 divided by the cube root of 2. Answer, cube root of 12 over 2. Did you get the answers correctly? If yes, very good. But if not, do not worry because you can play and play and play this video until you understand and get the correct answers. That's all for today. Thank you and God bless. Happy learning!